Okay, so welcome back. So now we're going to talk about equivalent equations for a moment, and then we're going to talk about what we call the addition principle for solving equations and the equality principle. Okay, so equivalent equations are two equations that have the exact same solutions. Okay, for example, if I have, let's see here, 2x plus 7 is equal to 13, and I have 3x equals 9, then these are what we would call equivalence equations because they have the exact same solution. In this case, 3, right? So if I plug 3 into both of these equations, they will give me a true statement, okay? So if I plug in 3 here, I get 6 plus 7, which gives me 13 equals 13. If I plug 3 in here, I get 3 times 3, which is 9, and I get 9 equals 9. So I get the same, I get true statements when I plug 3 into both of them. So these are what we call equivalent equations, okay? There's other thing that we want to talk about. I mentioned this before, but again, now I'm going to be exact about it. So a solution. So when we talk about solving an equation, that means we're trying to find a solution. So remember, if I say x equals 3, for example, in this case, I say x equals 3. What I'm saying is 3 is a solution. So I'm solving for x. Okay, so when we solve an equation, it means that I'm solving for the variable and I want to get in the form of x equals 3. Okay, and so that's what we mean by a solution. Okay, now, and if once we get it into into this form, which means we isolate x on one side. If we can isolate x on one side and we have a number on the other side and we get into this form, that's when we have a solution, okay? And we can show that it is a solution by plugging it back into the original equation. So now, the other thing too is about this addition principle, okay? But before we get into that, there's this principle called the equality principle. The equality principle means that when I look at this here, it doesn't matter what side I am. If 3x equals 9, or I can say 9 equals 3x. So there's an equality principle that says this side is equal to this side. Now, the addition principle follows from that, meaning that, hey, if I have an equation, I need to make sure that this equation stays balanced in a manner of speaking. So the addition principle says that whatever I add to one side, I have to add the same amount to the other side to make the equation still be equal, okay? Because if this is equal to this, and I add 3 to this side, well, now I've changed the equation. It's not the same equation, okay? But if I add 3 to this side, then now it's the same. Why? Because, again, if I put 3 in here, I'm going to get a true statement. I have an equivalent equation, right? So that's where the equality principle comes from. So as long as I have the same solution here, whatever I add to one side, as long as I add the same thing to the other side, I get an equivalent equation. Do you understand? So now, this also works for subtraction because, again, subtraction can be looked at as adding a negative, right? So again, the same thing is if I subtract a number from one side or add a negative to one side, however you want to look at it, as long as I do the same thing on the other side of the equation, I will end up with an equivalent equation, okay? So that's where the addition principle comes in, is that as long as I add or subtract the same amount to both sides of the equation, I will end up with an equivalent equation, and what I can do is I can use this to solve the equation, okay? Which means I want to use this addition principle to isolate the variable on one side and get all the constants on the other side and simplify, okay? So let's do an example. So here's a simple example. X minus 4 equals 2. So x minus 4 equals 2 is a simple equation, right? And I want to solve this equation for x, which means I want to isolate x on one side, and I want everything else on the other side, all the numbers, the constants, okay? So what do? Well, I'm going to use the addition principle to come up with an equivalent equation. So what can I do? Well, I'm subtracting 4 here, right? Well, I want to undo. I want to do the opposite of that. So if I'm subtracting 4, well, then I want to add 4. Because one thing you need to realize that there are what we call inverse properties. Inverse properties are operations or inverse operations. Inverse operations are operations that undo each other. So for example, the 4 operations that we've talked about, multiplication, division, adding, subtracting, okay? The inverse operations are adding and subtracting. Those two things undo each other. If I add 3 and then subtract 3, I end up going right back to where I started. The net effect is 0, right? 3 minus 3 is 0, right? Now, what if it's multiplication division? Those are inverse operations because if I multiply by 2 and then divide by 2, guess what? The net effect is 1, right? I multiply by 1. So it makes it basically leaves it unchanged, okay? So keep that in mind for next time. So what I'm going to do is, since I'm subtracting from 4 here, I want to add 4 to both, add 4, right? Why do I want to add 4? Because I know if I subtract 4 and add 4, this is going to add to 0. But again, the addition principle says whatever I do to one side of the equation, I have to do the same thing to the other side of the equation. So now I have to add 4 over here. Now what happens is, if I add down, what happens? This goes to 0, so all I'm left over on this side is x. The equal sign comes down, and then I have 2 plus 4. Now I have an equivalent equation. So what am I saying? I'm saying x minus 4 equal to 2 is equivalent to x equals 2 plus 4. And so now if I simplify this, I get x is equal to 6, and there's my solution. So now how do I check? I go back to my original equation and plug it in. And so now plug in 6 here, and I get 6, oops, not that. I get 6 minus 4 is equal to 2. Well, 6 minus 4 is 2. So I get 2 equals 2, and therefore it checks. Okay? And I did it right. So always check your answers to make sure that you did it correctly. Because if you don't check and you made a mistake, then you've got the wrong answer. So it's possible that you might have made a mistake here. The best way to check to make sure you didn't make a mistake is take your answer, plug it back into the original equation, and see if you get a true statement. If you get a true statement, you did it right. If you get a false statement, you made a mistake somewhere. Okay? Have a great day.